I come from Greece. I used to be proud of my origin because 2,500 years ago, in Greece, science was born, and also several other concepts like sophistry. It's a Greek word. There are many other Greek words very relevant, like philosophy, like democracy, like stochastics, to refer to some of the terms, or climate is another Greek word. In the last 10 decades, I would say I'm not so proud for my country because we have abandoned the ancient inheritance, and it is not only a Greek problem. I think the entire European Union is deteriorating in terms of science, in terms of democracy. So I think Hungary is an exception. And I'm so proud and so honored to have been invited to give this lecture here. And I thank the Academy for this very honorable invitation. I think Hungary keeps being close to reason, close to knowledge, and in terms of politics, which I'm interested in, but my talk is not about politics, of course, it's about science. My subtitle is The Holistic Refutation of Climate Science, and I have put climate science in quotation marks, and the reason is already explained by Professor Sarka, because he said this is not science, it is sophistry. I'm afraid my presentation is too long, and I'm afraid the chairman will kick me out, or anyhow. But you may find the presentation online in this URL here, so you will have the time, if you are interested, to see it, because I'm sure I will not be able to complete it. Anyhow, there are telltale signs that climate science is not science, it's sophistry. Mixing of scientific knowledge with politics. This is not science. But all these have already been explained by the first talk, so I can skip this slide here, and also I'll skip the second one about striking examples of misguidance by IPCC and climate scientists. So my talk will be based on my own research. So on the right, you will see you see a list of my recent papers in the last 5 years about climate. There are 14 journal papers and several other materials. And all these were heavily discussed in the blogs. These are for the Altmetric website, which measures the discussions about papers, informal discussions, not formal journals. And you will see that these are very heavily discussed. This means that the scientific community is aware of the papers. But during these 5 years, nobody has found any error in my papers. So this is very good sign for myself, and hopefully for science, anyhow. I'm not claiming that I'm not doing errors, but till now, no error was found. So what I'm talking today is based exactly on these 14 papers, and I tried to codify this research that I have done in 10 different points. I use the term decalogue. Decalogue is another Greek word, means not 10 commandments, but 10 words or 10 reasons. This is the logos, is the meaning. The meaning of logos is word or reason, it's the same thing. So, number one, climate change is real, and climate crisis too, but only in politics, the last one. Climate change has been real throughout Earth's entire 4.5 billion year history. Climate crisis is a purely political issue with no relationship to the real world. There is no greenhouse effect, forgive me if I sound provocative, nor greenhouse, I will explain what I mean, nor greenhouse gases in the atmosphere. These are misleading terms whose real meanings are atmospheric radiation effect, I use the acronym R, and radiatively active gas, RAG, respectively. The radiation effect mostly depends on the temperature gradient in the atmosphere. At the equilibrium, which is an isothermal atmosphere, the radiative effect is zero, and I will explain that. In case of temperature inversion, we have the opposite. We have cooling of the Earth, not warming. Number four, in the standard atmosphere, with the gradient of lapse rate of 6.5 Kelvin per kilometer, the radiative effect is dominated by water, not by CO2, which is playing a very minor role, 4 to 5%. And I'll also explain that. The century-long observations of long-wave radiation show no change in the radiative effect. I'll show data. The substantial increase of atmospheric CO2 from 300 to 400 and something ppm didn't give a discernible effect. So let me go through this. Oh, sorry. Okay. Number 6. There is no proof that the increase of atmospheric CO2 causes temperature increase. On the contrary, paleoclimatic and modern observational data support the reverse causality. Increase of temperature happens before that of CO2. Number 7, the carbon balance in the atmosphere is dominated by natural processes. Human emissions of CO2 are only 4% of the total. The increase of the temperature resulting in substantial increase of the natural emissions. The isotopic carbon data show changes in the atmospheric synthesis, but no sign of human influence on these changes. They show that the changes are driven by natural processes. Number 9, the dynamics of the atmospheric CO2 can be recovered from natural processes only. At number 10, in agreement with Professor Sarka said before, temperature increase in the 21st century is consistent with changes in the solar radiation absorption. So let me start with number 1, and we'll see what number I will reach before I finish my time. Climate change is real. You see here, this is a graph from my paper of 2024. In the upper, the upper graph is the temperature. You may see that the temperature rate at about 40 degrees during the last half billion years, yes. And in the lower graph, you see reconstructions of the CO2 content of the atmosphere, and here the range is more than 1 order of magnitude. What is also important is that these changes are driven by changes in the geology. You see here the different aeons like Cenozoic, Mesozoic, Paleozoic. These are also Greek words. And zoic means from life. Zoe is life. Okay, so it's life that has driven these changes. And you see some milestones of the evolution of life and the biosphere here. Okay, but I could also use some modern, let's say, data, but not that modern, because you see, we have data, we have data that start in 622 AD. Which data are these? The Nilometer data, the administration in Egypt kept records. This started from the ancient times, but we still have the records of the Byzantine and Arab period in written documents. So we have the blue line are the annual minimum levels of the Nile, the blue line, and the red line is the climatic values, which means that 30-year averages. So you will see here, for instance, in about 1100, the climatic 30-year average value of the minimum water depth in the Nile was 4.5 meters. In another period, let's say around 800, it was 2 meters. The climate was 2 meters. So we have also instrumental data. And a long record, this is 849 years, which shows that climate ever changed. What about the climate crisis? Of course, there are several who say that climate crisis is not real. I am one of them because I have signed the World Climate Declaration, which says the opposite. But here, I put it in a different way. You see, we have our European Parliament, and since 2019, it declared that we are in a climate emergency. In Greece, we have a ministry of climate crisis, and we are the only country in the world to have a ministry of climate crisis with this title. The United Nations declared climate crisis. So there is climate crisis, but this is just a political issue. And the Western politics has not, I claim that has lost connection with reality. In nature, there is no climate crisis, and my question is, what is more dangerous, a natural climate crisis or a political climate crisis? This is for you to answer. Why, number two, why I am claiming that there is no greenhouse effect? You see the photo? You see the photo? You see the real greenhouse is covered by low-density polyethylene. The low-density polyethylene does not have any effect on long-wave radiation. The long-wave radiation escapes. It traps not the radiation, it traps the air. That's the way the greenhouse works. The atmosphere is a total different issue. And this is known since 120 years. You see this publication here. There was an experiment by Hood in 1909, which showed that what happens in the greenhouse is not about long-wave radiation. It's about trapping the air. And this is also known to organizations like the American Institute of Physics, because I have here the quotation from their website, and they are fully aware, but they still use the term greenhouse effect. Why? For political reasons, of course, because it is a slogan that can touch the population. They also use terms like hothouse effect, blanket effect, etc. On the right, you see a recent paper, 2025, with my colleague, sorry, I cannot easily handle this equipment here in Frontiers. And in this paper, we propose the terms atmospheric radiation effect and radiatively active gas to replace this greenhouse stuff, which is totally incorrect. Okay, so I'll explain this more. The upper graph here is from a paper by Happer and, sorry. The red line is the radiation that leaves the Earth. The black line is the radiation that leaves the top of the atmosphere. And this measurement is from the first satellites in 1970, even though I used the paper by Happer here. What this graph says, that the radiation that leaves the atmosphere, the upper atmosphere, is higher than that which leaves the Earth. This means that the atmosphere cools rather than warms the atmosphere. And this happens when there is temperature inversion. So what we call greenhouse is not totally relevant to the greenhouse. It could be just the opposite. And the lower graph shows, is from a recent paper by Harde, and I forgot the name, and Snell. It is an experiment, a laboratory experiment, which verified exactly this phenomenon. What is the phenomenon? That the radiation that leaves the atmosphere could be higher than that leaves the Earth. So we have experimental laboratory proof that this phenomenon really exists. Okay, from this paper, this is a summary graph, because I don't have the time to explain the entire paper, a summary graph, and I have several cases here. For instance, this blue case is the realistic one, with average Earth temperature of 288 degrees. And this happens when? Can you see the pointer here? Is it visible? Okay. You see, this happens when we have radiatively active gases, and when we have clouds. Some forgot the role of the clouds, but also when we have the gradient in the atmosphere. If we don't have the gradient, if the atmosphere is isothermal, we have the blue line. So the atmosphere tends to be isothermal, but because there are changes all the time, for instance, we have day and night, it departs from the equilibrium, which is the isothermal atmosphere. So it is the gradient that increases the temperature from this case with no rags, with no radiative effect, to the actual temperature that we have now. And I have also made some additional experiment with temperature inversion, which shows that if there are radiatively active gases, their effect is to cool rather than to warm the atmosphere. Number 4, in the standard atmosphere, which is 6.5 degrees Kelvin per kilometer decrease, sorry. You know, the phenomenon, when we are in the mountains, we have lower temperature. This is dominated by water, vapor and clouds. There is a very popular paper by Lacis and Smith and others, which says that the non-condensing greenhouse gases, which means CO2 mostly, account for 25% of the total greenhouse effect, and without this, the Earth would collapse, plunging the global climate into an ice-bound Earth state. This is totally incorrect according to my calculations, and I have this paper here on the right that shows why this is right. I have proposed a different methodology about calculating the relative importance of each factor. And this is new methodology, is actually the classical mathematical methodology. You have a function of several variables, and in order to compare the effects of the different variables, what you do? You take partial derivatives, so simple. You see here the equation, the partial derivatives, and you compare the partial derivatives. The important thing is to use the current state in order to calculate the partial derivatives. Not compare what would happen, like I showed before, not compare what would happen without RAGs, but with the current RAGs, state of RAGs, what is the influence of the different factors. And for this, I have used a standard orthodox model and derived a macroscopic relationship describing each of the factors, and then took the partial derivatives, and that's the outcome in graphical form. 50% in this radiative effect comes, or greenhouse effect if you wish, comes from water vapor, 45% from clouds, 4% from CO2, and all other 1%. This is for the downwelling radiation that reaches the Earth, from the atmosphere to the Earth, and for the outgoing, it's a little higher. CO2 is 5%. Okay. This perhaps seems strange to some, but I have also evidence from data. The graph that I showed is from a standard model, acceptable by orthodox and skeptics. Now I have done some research using data, and we have data for more than 100 years. It actually, it happens to be a water scientist, hydrologist, let's say. So I have used this in routine calculations throughout my career, because climate scientists may speak about greenhouse effect, but hydrologists calculate what is this thing and how it affects several phenomena like the evaporation. And we use evaporation in hydrology because we have to design engineering projects, we have to calculate the needs of the plants in order to irrigate them, etc. So we do this for 70 years, we do these calculations, and the data exists for a period more than 70 years, more than 100 years. And the first who published such measurements of long-wave radiation is Angstrom. I'm sure that you know the name Angstrom. So this is the result. We have collected several data sets, and here we have the measured, on the horizontal axis, we have the measured, and then we have the calculated by Broodside's formula, which takes into account only the atmospheric moisture, not CO2 at all. Because, why not CO2? Because CO2 is unimportant. That's the reason. So, I will not have the time to explain in full detail the graph, but if you read the paper, you will see that there is no discernible effect throughout these 100 years of any influence of CO2. And this confirms the theoretical result that the CO2 effect is 4%. But it is 4% on the radiation effect. Does it mean that it indeed produces temperature increase? Okay, this is another issue, and we have started with my Polish colleague Koutsoyiannis, who is also an IPCC member and a very high-level member. And we started this because of the COVID experiment, because during the COVID period, there was a decreasing of the atmospheric emissions, but there was no change in the increase of atmospheric CO2. And that triggered our research. And we thought initially that the CO2 temperature problem was like a hen or egg problem. But eventually, we studied this issue further, and we published 2 papers in the Proceedings of the English British Royal Society, and you see the papers here. And we found surprising results. It was also surprising for us. We didn't expect that. First of all, in order to explain the methodology, we didn't use an established methodology. We developed a different methodology for causality detection, and we did that because we discovered problems in the existing methodologies. We decreased our aim in order to find just necessary conditions. It is very difficult to find sufficient conditions for causality. Perhaps it is impossible, but necessary conditions is easier. So we used a modest objective. Necessary conditions are very important in deductive setting to exclude, to falsify a hypothesis. And science progresses with falsifying hypotheses. It's very important. But also in an inductive setting, it is good to add evidence in favor of a plausibility of some hypothesis. We used stochastic processes and not simply events. We used only real data. We excluded categorically anything coming from climate models. We expressed our method in terms of hen or egg connection, bidirectional, and eventually the method is able to find also unidirectional causalities. This is very, I would say that mathematics is simple. We use the IRF, impulse response function, which is an old concept. We use this concept to detect causality. And these are the results from temperature and CO2 data. This is the response function. It has negative time lengths, and positive time lengths. When we treat the system with first variable, the temperature, second variable, the CO2, we find that all coordinates at the negative part of the axis, time lag axis, are 0. This means that the temperature is the cause and the CO2 is the result. If we make the alternative hypothesis, first CO2, second temperature, we take the opposite graph, which says all the coordinates, the positive coordinates, are for negative lags, and for positive lags, everything is 0. This means, again, that temperature is the cause and CO2 is the effect. So we can exclude the popular theory that CO2 produces changes in temperature. This can be excluded because it violates a necessary condition. The other one, we cannot guarantee that temperature, but we have some evidence that it could be plausible. We further developed this method. You see here on the right 2 publications where we did much more detailed works and use also data. And I can leave this quiz here to see and tell me. The green line is CO2, and I put it as a quiz. The green line is CO2, the red line is temperature. These 2 are lagged by 6 months, halfway before, halfway past. Okay. What is the cause and what is the effect? I'm not giving the answer. If you want, I can also provide these two graphs. In the horizontal axis, it is the temperature change per year. In the vertical axis, it is the change in CO2. Here we have 6 months later. In the lower, it's 6 months earlier. Which is the cause and which is the effect? Here we have a coefficient of correlation 0.75. Here we have 0. Okay. Now, again, similar results with another data set. Again, we have 0 everywhere in the negative part of the axis. And 0, if we change the setting, 0 in the positive part of the axis. These are data, Mauna Loa and SEP and CAR reanalysis. If we take outputs of climate models, you see everything is reversed. The climate models have the wrong, incorporating the wrong causality direction. And of course, the entire climate science and the entire IPCC has incorporated the wrong causality direction. Okay, some colleagues like Asbrig, who is also a member of Clindell Marshall, has criticized me. Many other skeptics have criticized me of making arbitrary extensions of the results, because they say this can happen in annual or subannual scale, but if we go to core cell scales, like the decadal scale, then this is reversed. But they didn't provide any calculation. So here is my calculations. I made again the IRF, the impulse response function, for the decadal scale, and again, the results are exactly the same. And you see here diagrammatically that the relation between CO2 and temperature is maximized in terms of correlation when at the decadal scale, when there is a lag of 1 year. So a similar result. And we also provided a toy model which fully reproduces what is measured about climate. This graph is used by my critics, and my answer is, okay, you say that I'm wrong. This is what my model produces, and it is exactly what is measured. And the model is very simple. You can make it in an Excel spreadsheet. No programming, special programming tools, no AI, no Grok, no ChatGPT. Very simple. The other paper used several data sets. I've already showed you one of them. The entire Phanerozoic, more than 500 million years, Cenozoic, Quaternary, Common Era, Modern, in every data set we have positive lags. CO2 is a result of temperature. Temperature changes first, then changes CO2. And this is not only for this paleoclimatic data, but also for the modern instrumental data. You find it difficult. See what happens. Here we have on the left, the graph on the left, the horizontal axis, we have the soil temperature, degrees Celsius. This is the respiration of the plants on the vertical axis. And you see, it increases exponentially with temperature. The respiration of the plants, of the microorganisms in forests, we have an exponential increase. And if you find hard to believe, just meditate on the photos on the right. We have a tree in 2 instances, and think when the tree produces more CO2 and emits more CO2 in the atmosphere, in the summer or in the winter. The respiration, okay. The total respiration used to be 111, what is my, gigatons of carbon per year, and it was in the pre-industrial period. Now it is 136 or more, and I'll explain what I'm saying. So we have 10 gigatons emitted by humans here, and 9.4 plus 1.6 anyhow. And we have these red bars, the increase of the total respiration and the increase of the respiration in the oceans. So it's 4 times higher is the increase due to increase of temperature, the increase of natural emissions of CO2. If we take the absolute values, then the human is 4%. Okay. You can see this also in this graph. Usually, the graphs that we see in the media, in the IPCC, concern only this black part here in this graph, which is the human emissions. But if you see the entire picture, you will see two things. First, the natural emissions are huge compared to the human. And also, the natural emissions are concave. You see the concave curve, they have increased a lot. And I call this the streetlight effect because of this, very known joke about where to search. The policeman and the drunk who lost his key. Now, this is not a modern issue. This starting from Arrhenius, who is the founder of the CO2 hypothesis, greenhouse hypothesis, okay. Who said, and this is the yellow part here is a copy from his paper, where he says, eventually he says that we can omit the combustion and decay of organic bodies and the consumption of CO2 by vegetative processes. This may be omitted. These are now 96%. At his time, they were 99.75%. And he says, neglect the 99.75%, and the only thing that matters is the 0.25%. That was his thought. But it's not only Arrhenius. This graph now, here we have the year in which we have a published estimate of the natural reaction. This is photosynthesis, the absorption of CO2 by the trees. They thought in the beginning of the 20th century, they thought that this is, let's say, 15 gigatons per year. The current estimate is about 160, and the current estimate of the difference between now and what happened in the pre-industrial period is almost 50. So this is the change of the natural emissions. This is the change of the natural emissions, okay? By trees, etc. This is what Arrhenius said, and the other researchers of the period until now said. Then we have another person, very important figure in climate research, Killing, who started the measurements, systematic measurements of CO2. And this graph I made reproducing his own graph because he gave the values of what he measured in a table form, but he didn't use La Jolla. Why? Perhaps he didn't use it because he didn't like it. Because La Jolla, one of the 3 stations he established, shows a very pronounced effect of seasonality, which means of the plants, of the respiration, okay. And he eventually, established his hypothesis of human-made CO2 only using the blue line here, which is the South Pole plot. I have also his quotations of his paper. Now, number 8. The isotopic carbon data did not show any sign of human influence. This is another paper, again 2024. And before I'm going to a paper, I have here a quotation from IPCC, the last report, which gathers multiple lines of evidence to establish the dominant role of human activities, etc. And you see, this evidence is categorized in 4 different cases. And in the last one here, the IPCC report cites Suez and the known Suez effect, known to many, I guess, which thought that isotopes establish the finding that the increase of the atmospheric CO2 is of human origin. But this is not exactly what Suez said, because I have also quoted him. At present, it is not possible to make conclusive interpretations concerning the reasons for the difference between the individual samples grown at the same time. Actually, his samples were only 4. You cannot, of course, using 4 trees, you cannot make results about the global climate. Okay, now what the paper says. The upper graph. We have 2 things. One is the atmospheric content in terms of the isotope 13 of carbon, which is a stable isotope, so no nuclear reactions anyhow. And another quantity is the input from the ground, from humans, from whatever, to the atmosphere. This is another issue. This is another concentration. Now, if you see the atmospheric CO2 content, you see a decrease. You see a decrease through the years. But if you take and find the input signature, you see an increase. Okay, so this doesn't mean that this comes from the CO2, of the CO2 human emissions. And of course, there are many more reasons to reject this hypothesis. This, for instance, the plants have lower CO2, 13 carbon signature than the fossil fuels. Number 9, the dynamics of the atmosphere can fully recover for natural processes only. I have here 2 graphs and another quiz. Spot the difference. The one graph is without considering at all the human emissions, and the other graph is considering also human emissions. Find the differences. And I'm going to my conclusions. Just to say one more word, temperature increase in the 20th century is consistent with the changes in the solar radiation absorbed by the Earth, and you see how the absorbed solar radiation, again using data, not models, data, CERES, satellite data, you see that there is an increase. And this increase can fully explain the energy imbalance in Earth. The energy imbalance is calculated in 0.75, and just the shortwave radiation explains 0.9. It's 15% more than this, 27. Okay, so coming to my conclusions, human CO2 as the climate control knob is empirically attainable once we properly account for natural CO2 fluxes, which is 25 times larger, the effect of water, vapor, and clouds, which is 20 times larger, and the huge complexity of the climate system, including the biosphere's role, which is very important. Climate models are in disagreement with observations while reversing cause and effect. In complex systems, data are sovereign, and data have falsified the mainstream climate theory. I'm sorry, Mr. Chairman, for that. The emission-centric paradigm was a political project that constricted science to provide authority. Climate science is therefore not just corrupted science, it is more than that, it is purpose-built instrumentation wearing the lab coat of science while abandoning its method. And scientists' job is to kill bad theories and rip back science from politics, not posture as saviors of the planet. And my last, thank you very much.